addition of surds. We have, for example, let's say we have root 2 plus 2 root 2. What's the result when we add them together? Addition of surds is like addition of algebra. Let's say in this case, this root 2 can be, for example, under algebra A. So we have A plus 2A. Using this question, A plus 2A can be 1A plus 2A, which gives you 3A. In surds is similar. This is the same thing as 1 root 2. Since they both have root 2's, they are like terms. So you pick one of the root 2's, same as you pick one of the A's when you're adding 1A plus 2A. You pick the A and add the numbers. You add 1 plus 2, that's 3. Same applies to surds. You say 1 plus 2, that's 3. So your answer of adding root 2 plus 2 root 2 or 1 root 2 plus 2 root 2 is 3 root 2. Another method of doing this is like we factorize. We have 1 root 2 plus 2 root 2. Both of them have root 2's, so you bring out root 2, put in a bracket. Then you have 1 plus 2. 1 plus 2 in bracket. 1 plus 2, that's 3 root 2. Same answer, two different techniques. I know most of you prefer this. This is quite easy for students to work with. So we'll go to the next question. We have 2 root 2 plus 3 root 2 plus 5 root 2. They all have root 2's. You pick one of the root 2's, then you add the whole numbers together. You have 2 plus 3, that's 5. 5 plus 5, that's 10. So you have 10 root 2 as the answer to the second question. A third question. What if in this case you have 2 root 2 plus 2 root 3? You have root 2 here and root 3 here. In algebra, this can be related to unlike terms. Let's say, for example, you have 2a plus 2b. You can't add them together. You leave your answer as 2a plus 2b. Nothing can be done to it. Same as this. Let's say root 2 stands for a and root 3 stands for b. So in this case, we can't do anything to this. The answer to this question is 2 root 2 plus 2 root 3. We go to a fourth question. We have 2 root 2 plus 2 root 3 plus 4 root 2 plus 3 root 3 plus 3 root 5. Now we have all of these. We have this one with root 2, this one with root 3, this one with root 2, this one with root 3, and the last one with root 5. So we do like we do in algebra, we collect like terms. The one with root 2 are similar surds or like terms. So you have 2 root 2, then the next one with root 2 is 4. So you have that plus 4 root 2. Since we don't have any other root 2, we go next to the root 3's. So we have plus 2 root 3. The next one with root 3 is 3 root 3. It owns the plus in front of it. So positive 3 root 3. We're done with the root 3's too. Then the last one is 3 root 5. Then you have 3 root 5 as the last one. Now we add the root 2's together since they are like terms or similar sorts. The one with root 2's, you pick one of the root 2's. Then you add them together. 2 plus 4, that's 6. So you have 6 root 2 plus, these two have root 3's. They are similar sorts or like terms. We have root 3, then we add the whole numbers together. 2 plus 3, that's 5. So we have it as 5 root 3. Then the last one is plus 3 root 5. We leave it as 3 root 5. So this is the final answer to this question, where we have 6 root 2 plus 5 root 3 plus 3 root 5. They are unlike terms, so this is where we stop. It's just like when we have algebra, you can put it in this case, you can have 6a plus 5b plus 3c. You can't add them together, you leave them as this as your final answer. Root 2 is like a, root 3 is like b, and root 5 is like c. You have it in this form where this is our final answer. The fifth question we have square root of 45 plus square root of 20 plus square root of 32 plus 3 root 2. In surds, it's not allowed. Let's say, for example, you have square root of 45 plus square root of 20. You can't say square root of 45 plus 20. It's not allowed. It's not equal. They don't equate to one another. In surds, you can't say because you have a square root of a number added to square root of another number. You pick a bigger square root, then add the numbers together. No, it doesn't work in surds. And a simple example can be shown to us. Let's say, for example, let's use a perfect square. We have square root of 4 plus square root of 9. Would it be the same as square root of 4 plus 9? Square root of 4 is 2 and square root of 9 is 3. 3 plus 2, that's 5. On the other side, we have 4 plus 9, that's 13. Square root of 13 is 3.606 approximately. You see that the answers are not the same, they don't equate to one another. That's why in surds, you can't have something like this. We can't have square root of 4 plus root 9 as square root of 4 plus 9. It's not possible. But in the case where you have square root of 4 times square root of 9, it's the same thing as square root of 4 times 9. Let's say, for example, square root of 4 is 2, square root of 9 is 3. 2 times 3 is 6. Square root of 4 times 9 is 36. Square root of 36 is 6. You see that we'll get the same answer when we find their square roots separately and multiply them, and when we group them under the same square root, multiply them, and find the square root, they are the same. So under multiplication, we can choose to either give them their separate square roots, or we join them under one square root. By now, we should be very good with converting from a surd in a single form to its basic form. We have 45. Of these, we know 9 can go in 45. 45 as 9 times 5. The next one is 20. What perfect square can we find in 20? We have 4, we can find 4 in 20. So we say 20 can be broken down into 4 times 5 plus. The next one we have is 32. We have 32 as 16 times the number, because 16 is a perfect square and 16 can go in 32. So we have 32 as 16 times 2. Then the last one is already in the basic form, that's 3 root 2. That means when you're working with surds, you have to break them down from their single form to their basic form. And I have not completed this. The ones that are linked by times, you have to give them separate square roots. So we have square root of 9 times square root of 5 for the first one, plus square root of 4 times square root of 5 for the second one. Then the third one, you have square root of 16 times square root of 2. Then for the last one, which is already in its basic form, we have 3 root 2. We can go on further to break down this square root of 9, since it gives you a whole number, is 3. Then with the root 5, that's 3 root 5. You can join them together. Plus square root of 4 is 2. Then you still have the root 5 linked to it by times. Root 5, you join them together. Plus you have square root of 16, that's 4. Then join to the root 2. Then the last one is 3 root 2. Now we'll see the like terms, root 5, then root 2. The ones with the root 5s are similar, or like we say in algebra, we say like terms. Then the one with the root 2s are also similar. So the one with the root 5s, you pick one root 5, then you add the whole numbers together. You have 3 plus 2, that's 5. This is just adding surds that are like terms. Then we have plus 4 root 2 plus 3 root 2. They are like terms, or they are similar surds. So you pick the root 2 first, then you have plus 4 plus 3, or 4 plus 3, that's 7, or you say plus 7. And since this is root 5 and root 2, and they are not like terms or they are not similar, we leave this as our final answer. That's 5 root 5 plus 7 root 2. This is the final answer to this question. We move to subtraction of surds.